Hi, I'm Chris and I'll be showing you how to solve number 6 of the 2002 AP Calc AB FRQ. Let f be a function that is differentiable for all real numbers. The table above gives the values of f and its derivative f prime for selected points x in the closed interval negative 1.5 to 1.5 inclusive. The second derivative of f has the property that f double prime of x is greater than 0 for this interval. So for this problem, we're given that the interval from negative 1.5 to 1.5, and that on this interval, the function is differentiable, and that f double prime of x is greater than 0. This implies that the function is continuous, and this also tells us that the function is concave upward. A. Evaluate the integral of 3 f prime of x plus 4 dx on the interval 0 to 1.5. Show the work that leads to your answer. Since we're unable to take the integral of the original expression, we're first going to have to break it down into smaller pieces. Now that we're in two separate pieces, we can integrate both of them and then combine them. Now we just need to plug in the x values, and for f of x, we take the values from the table. And now all we have to do is solve. Which gives us the answer 24. B. Write an equation of the line tangent to the graph of f at the point where x is equal to 1. Use this line to approximate the value of f of 1.2. Is this approximation greater than or less than the actual value of f of 1.2? Give a reason for your answer. This problem has three parts. The first of which is find the equation of the tangent line at the point x is equal to 1. From the table, we are given that f of 1 is equal to negative 4, which will be our b value, and that the first derivative of 1 is equal to 5, which will be the slope of the tangent line. In y is equal to mx plus b form, we can write our equation as y is equal to 5 times x minus 1, which is m minus 4. In the second part, we are going to approximate the value of 1.2. To do so, we just plug in the value for x. So y 1.2 is equal to 5 times 0.2 minus 4. So this, we find that our approximation is equal to negative 3. The last part of the problem is to determine whether or not our approximation is greater than or less than the actual value. In the original statement, we are given that f double prime of x is greater than 0 for all values on the interval. This means that the function will be concave upward, and because of this, our approximation will be less than. C. Find a positive real number r having the property that there must exist a value c with 0 is less than c, which is less than 0.5, and f double prime of c is equal to r. Give a reason for your answer. The mean value theorem states that there must be a value c where the secant and tangent lines meet. The function is continuous and differentiable on a closed interval. The original statement tells us both these things are true for the function, and therefore we are able to use the mean value theorem. Here we have the equation f prime of b minus f prime of a is equal to f double prime of c times b minus a. Because f double prime of c is equal to r, we are trying to solve for that. When we plug in the values, f prime 0.5 minus f prime of 0 f double prime of c times 0.5 minus 0. Now when we solve for that, we're given that 3 minus 0 is equal to f double prime of c times 0.5. And when we divide by 0.5, we're given that f double prime of c is equal to 6, which is therefore equal to r. D. Let g be the function given by g of x is equal to 2x squared minus x minus 7 for x is less than 0, and 2x squared plus x minus 7 for x is greater than or equal to 0. The graph of g passes through each of the points x, f of x, given in the table above. Is it possible that f and g are the same function? Give a reason for your answer. The simple answer to this question is no. In the original statement, we are told that the function is differentiable at all points, which also means that it is continuous. One way to test continuity is if the limit is defined for every point. For g prime of x, when we test the limit of x going to 0 from either side, we see that there are different values. For the left side, we see that it is equal to -1, whereas coming from the right side, we see that it is +1. Because these two values are not equal to each other, that means that there is no limit at the point x is equal to 0, which means that therefore g cannot be equal to f.